The intercepts of any graph, any curve, are the places where the graph crosses the axes. So the x-intercept is where the graph crosses the x-axis. The y-intercept is where the graph crosses the y-axis. A line of the form, like you see, an equation of the form, like you see here, negative 3x plus y equals 6. It's often referred to as the standard form for a line. It's a linear equation, so as long as nothing terribly exciting is happening with either x or y, no squaring, we're not dividing by x or y, anything like that, just basically multiplication and addition. In that situation, you have a linear equation. This is a linear equation in two variables, the two variables being x and y. And the two-dimensional representation of that is a line. Okay, so going back to the idea of intercepts, the x-axis is all the places where y is equal to 0. If we actually set y equal to 0 in the equation you see here, well, if y is 0, then we have negative 3x must be equal to 6. And so it follows from that that x would have to be negative 2, I guess. So let's go ahead and say that so negative 2 is about here. Actually, I'm going to wait a second until we talk about the. You just write that down here. So, oh, wrong drawing thing. Sorry about that. Erase. Try again. Okay, so again, if y is 0, we got x was negative 2, so negative 2 comma 0 is the x-intercept. INT for intercept. In the same sort of way, if we were to set x to 0, well, then of course, y would be 6. So 0, 6 is the y-intercept. Okay, now I'm ready to draw this. So, try a different color. Excuse me. Okay, so negative 2 for x, positive 6 for y, and I'll just go ahead and say it looks like that. It actually meant to engage the straight line drawing tool, but actually didn't do too bad of a line. Okay, so the slope of this line obviously is positive. If you look at the line from left to right, it's going up, it's increasing, the graph is increasing, and if you look at any other part of the line, it would be the same line, it would have the same slope. The slope can be calculated by looking at the 2 points that we have here. So if you look at the change in x compared to the change in y, I guess red works. M would be equal to, well, the change in x would be the difference of the x values. So we have that in the denominator. 0 minus 2, negative 2, or negative 2 minus 0 makes no difference. Let's go with negative 2 minus 0. What does matter is if I go with negative 2 minus 0 in the denominator for the change in x, then the change in y has to be done in the same sort of way, so that would be 0 minus 6. If you do this wrong, then you get the wrong sign for the slope. So 0 minus 6. So that works out to be negative 6 over negative 2, and of course, negative divided by negative is positive, so we end up with a positive 3. So remember what that means in a certain sense is if you look at 2 points on the line, every time you go one unit, well, if you were to measure the difference, how far you went in terms of x from one point to another, you would go 3 times as far for y from one point to another. If you take 1 step to the right, you go 3 steps up. So if we were to start back here at the point which was as negative 2, 0 on the x-axis, If we were to go 1 unit to the right, which would take us to -1, well, we would have to go up 3 units, which would take us to -1, 3. And if we were to go another unit to the right, well, then of course we're looking at -1 plus 1 or 0, and we would go up another 3 units. 3 plus 3 would be 6, and sure enough, we get the y-intercept in that case, 0, 6. Now, if I take the original equation, let me go ahead and just throw in the -2, 0 point here for completeness. You've got 3 points, and if you were to do this on graphing paper, they would all line up nicely. If we go back and look at the original equation, as you probably recall, doing a little manipulation of this and solving it for y, we would get an equivalent equation by adding 3x to both sides of the equation. We get y equals 3x plus 6. And that's in what's called slope-intercept form. The reason it's called slope-intercept form is because the slope and the y-intercept figure significantly here. Specifically, 6 is the y-intercept. It's a matter of perspective. 0, 6 technically points have 2 coordinates. However, it's pretty common to just go ahead and say that the y-intercept is 6 because everybody knows, if they understand the concept of intercept, then they know that the x value is 0, so we don't have to say anything about that. In the same sort of way, you could say that -2 is the x-intercept, and that's clear because if it's the x-intercept, then the y-coordinate at that point has to be 0. So the slope-intercept form, this is also referred to as the y equals mx plus b format. As mentioned earlier, m is commonly used for slope, and then b is the y-intercept. You may wonder why b? Well, really the only reason is that if we weren't using m specifically to stand for slope because it comes from Monte in French, well, we'd be using a because that's the beginning of the alphabet, and so essentially B is the next letter after A, but we're not using A here. We'll see more of this later on in the term where we look at generic type formulas for other sorts of equations. You've seen it before, for example, with the quadratic formula where you have a quadratic in the format ax squared plus bx plus c, where a, b, and c are standing for the constant values that you have in a particular case. Okay, we'll have more to say on this later, but for now we'll go ahead and call it good.